it's time for us to get started. My improvement has not been great, so tomorrow is also going to be online. I'll tell you that right now. I'm hoping, against hope, that I finally break the back of this thing and I'll be fine by Friday. We shall see. I hope so. My antibiotics finish up on Friday anyway, so it better be fixed. So we're starting a new chapter. And it's basically about graphing functions. And we're going to look at different situations, and they kind of fall into these four general situations. The first one, we're going to look at single functions. That's just like, oh, I know, f of x equals x cubed, f of x equals 2x plus 1, right? Single function, and how you can do sketches and graph them, and be essentially finding a table of coordinate points. And that's very simple, really. I mean, unless you try and make it difficult for yourself. Those types of questions, for the most part, are going to be pretty easy to do, and we'll do those. And then we move on to piecewise functions, which are functions that are basically broken into two or more pieces. And for different values of x, you use a different formula. And we're going to look at those, and we're also going to do those with a table of points. And those are not easy. Those are quite messy. And then our third category is going to be, well, we can actually use in many situations Desmos or our calculator, our TI calculator, just to graph the thing. The typical questions you get in the homework are, here is a function, here are 4 pictures, which one am I? So you can imagine you could plug it into your calculator or Desmos and say, the third one looks like it fits best. And the last group of questions right at the end, I'm not sure if we'll get to them today, but if we do, that's great, is suppose you're given the graph of a piecewise function. Can you actually find the formula that would generate that graph? And that, again, is quite difficult again. So it kind of goes easy, hard, all the way through. So first question is going to be, here's a function, and we'll just do a table of values. So I'll pick mine. Suppose we have a function, and it's 2x squared take away x. And typically in these kinds of questions, they even tell you the x values to use. So let's suppose they tell you to use -3, -2, -1, 0, 1, 2, and 3. And here's going to be f of x. Well, it's quite time consuming, but essentially you just plug -3 in here and get the answer. -2, -1, 0, 1, 2, and 3. And you could certainly do that as 7 individual calculations. But I'm a great believer, if there's a more efficient way to do it, then we should. And so let me show you an efficient way of doing that same thing. And the easiest way to do this would be to use a feature on your calculator, which is tables of values. So let's click on this guy. There we go. So 2x squared minus x. So you type in y equals, and you go 2x squared take away x. And then you go to second table setup. And in my table, I'm going from -3 to 3, and I'm going up in steps, say 1. And I could certainly set it up to work that way, but I'm actually just going to be lazy. And if you just make this one here independent and make it ask, you can actually then use it to do any values of x you like, and actually in any order you like. And that is me as a little bit more versatile. So I'll now go second table. And the first number was -3. And then x is -2. then -1, and make sure I hit enter when I do that, then 0, 1, 2, and finally 3. Yeah, that's how easy it was. So I'm writing these guys down, and then I'll zoom over to the screen. We've got 21, 10, 3, 0, 1, 6, and 15. Now, I don't have any square paper with me, so my pictures and graphs are going to be a bit ugly, but pretend that I did a good job. You take this table of values and you choose nice square paper, so pretend that's this square paper, and you pick appropriate scales. So maybe 1, 2, 3, -1, -2, -3. And now, since I need 21 as my biggest answer, I'm not going to do one box that equals 1, because I'd never reach, the place I need to go. So I'm going to do, what am I going to do? 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to choose a scale 4, 8, 12, 16, 20, 24, and 28. Or 2, 4, 6, 8, 10 if you've got the room. And now I'll plot some points. -3 and 21 is about here. -2 and 10 is about here. -1 and 3 is about here. 0 is 0, which is here. And then basically 1 gets you 1, so it's about here. 1 gets you 1, that's here. 2 gets you 6, which is about here. And 3 gets you 15, which is about here. And then you try your best to draw a curve, and then you label your curve 2x², take away x. And I've now drawn a sketch, maybe not the most accurate one, of course, but it's a sketch of this function. Seem okay? Any questions? Table of values, get that guy. Plot a whole load of points, 7 points in this case. Join them up by a curve, because curve seems most obvious shape that you're going to get through points that look like that. All look good.
Sorry to interrupt. I missed the part when you set up the function in the calculator.
Okay, let me do that again for you.
Thank you. Sorry.
No problem. First, I'll make sure that we're on the right page. Can you see the calculator in front of us?
Yes.
Okay. Now, I'm going to just delete some answers, just so you can start with like a clean slate. So first thing you do is you press y equals, and you type in whatever the function is going to be. So in this case, it's 2x² take away x. You then go to table setup, second table setup. And if you have the table set up the way I have here, that guy's 0, that guy's 1, doesn't really matter. As long as this guy here says ask, then you don't need to do table setup again. It's going to work every time. Right? Once that's set up, you then go to this guy at the end, second table. There we go. And now I can put in the coordinates that they want. For my table, it's the x's start at -3 and they finish at, I believe it's +3. And those are the guys that make up my table. So for instance, this top one, would correspond to the point with an x coordinate of -3 and a y coordinate of 21. And I would plot that point. And I'd plot all the other ones, and I'd finish with an x coordinate of 3 and a y coordinate of 15. And provided I've got pretty decent square paper and I'm careful about the scales in which I use, you would end up with a nice happy face, something similar to that one. We good?
Yes, thank you for that.
Right, so let's show you other versions of that same issue, because WebAssign likes to do things in different ways, even although it's essentially the same thing. Now, if I was going to do question 2, 5 minus 2x, I could fill in that table of values, right? And I would, using the method that I just showed you. I'm going to be a bit lazy here. I'm only going to do the first and last one. When x is -2, the answer ends up being, I believe, 9. And when x is 4, the answer ends up being -3. And can you imagine all the other ones being filled in? Now, on this situation, and rather than have 4 pictures and you pick which one looks like the answer, which is kind of what I would have done in the first question, we have to actually draw this guy. Now, you do, I hope, recognize that it's a straight line. And so if you've not used one of these, this particular feature in WebAssign, it does allow us to draw straight lines pretty well. So it's 5 minus 2x. So I only need to start at -2,9 and finish at 4, -3. So I'm going to have to shrink that one more so I can actually see those numbers. There we go. So I'll click on this guy and I'll do that one. And -2,9 is here, -2,9. And 4, -3 is 4, -3 is there. And do you see I've got my straight line? Now, if you go over here and it says line 1 and you're hitting that little guy there, you can just double check that you plotted those points in correctly. So -2,9 and 4, -3. Now you might say, well, what about all these other points in the middle? How come I never used them? Well, if I did use them, they'd just be dots like here, 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 and here. But WebAssign realizes that for a straight line, don't you only need to know 2 points? And I decided to pick the first and last, but I could have chosen the first point and the second point, and it would have still drawn the same line. Similar kind of thing here. Now, suppose we're doing a quadratic. Do you see that you've got a table of values that you plug in? Kind of weird way of doing it, but basically when x is 0, f of x is the negative of nothing squared, and that's 0, because negative nothing is 0. When you pick 4, 4 times 4 is 16, but then you make it negative. So both of those guys are going to be -16. This guy here is going to be -9. Those two guys, both of them are going to be -4. And this last one here is going to be -1. Now, if you plot those points on a grid, I know it looks a little bit weird, but you've got to think of that as 2 distinct points. It's the point 4, -16, and it's also the point -4, -16. And can you trust me that that's the shape you would end up looking like? I get that right? No, I did get it right. Wrong. It's that one. It'd be that shape. Now, here's another guy. Plot your points, draw your picture, and it will look like one of them. Plot your points, draw your picture, it will look like one of them. Do I need to do another one of these quadratics? Are you comfortable that you get plenty of practice doing the table of values and plotting them? Or would you like to see one more done? It's up to you. Give me a clue, guy. Feedback. Do some more, or you're cool so far?
I understand at least. I don't know about the others.
Oh, that's all you can say, what you feel. Anybody feel differently? Okay, then I will assume that these questions are basically just fill in a table, plot on paper your shape, and one of these four guys should look like your guy. Same idea, same idea. Lots of same ideas. Oh, wait a minute. Question 11. I'm going to show you, hopefully you know this, but just in case you've forgotten, I'm going to show you an absolute value question because we haven't spoke about those guys. So we have a function. It's h of x equal to the absolute value of x add 3. And typically I would do this on the calculator, and you can do that on the calculator, nothing wrong with that. I'm just going to do it by hand, excuse me, to emphasize something. We're being given x from -6, and our function is h of x. So we're going to do a -6 all the way down to 0. Interesting combination. -5, -4, -3, 2, 1, and 0. The main thing that you need to remember is when you see an absolute value, it means the positive numerical value of the answer. So if the number in the middle ends up being 7, the absolute value of it is still 7. But if the number inside ends up being, say, a -2, the absolute value will make it 2. So if I was going to do the first one, it's going to be -6 add 3. Well, that's the absolute value of -3, and that becomes 3. Now the next one would be the -5 add 3, which gives you the absolute value of -2, and that is now 2. Almost done with these guys. -4 add 3 gives us the absolute value of -1, which becomes 1. And if you plug in -3, you get 0. If you plug in -2 here, you get 1. If you plug in -1, you get 2. And if you plug in 0, you get 3. So there is your table of values. These points are now going to be sketched. And so imagine this is me on nice square paper. And I'm going to do x from -6, -5, 4, 3, 2, 1, and 0. So I guess I'm only using this side. And I only need to go up to 3, so that scale is going to work pretty well. -6 gets me 3. -5 gets me 2. -4 gets me 1. -3 gets me 0. And then it builds up again. It goes 1, then it goes 2, and then it goes 3. So what we end up with is 2 straight lines that look a bit like a V. And that's basically how you deal with absolute values. Now, if I return to the homework question, now that we've done that one, the picture, oops, the picture that we did that looked closest to this one was this one here. We actually only got to do the bit that went from here to here, but you have to imagine that the shape continues. So that would be the correct picture. There's a different one with an absolute value. And that is us finished with the first group of questions, which is how do you sketch the graph using a table of values? So finish the table, plot the points, join them up. If you need to, continue the shape so that you can look at the picture choices in the homework and pick the one that looks like that one. Any questions? Now, the second, basically, checks that one off. The second thing that we're going to look at are how do you do piecewise functions and tables of values. So I'm going to zoom a little bit out of sync here and find the questions where you have piecewise functions. So I think it starts at 18, but let's double check I didn't miss anybody. No. So we are going to start at question 16, 17, there's probably a few more, 18, yeah, 19, 20, 21, 22, there to 22, 16, 18, all the way up to 22. So there are quite a fair bunch of these guys. Now, we are going to be given a piecewise function, and we are going to sketch it. Excuse me. And we're going to do it with the table of values. Excuse me. So let's pick one of my own. Suppose we have a function f of x, and it is x squared minus 1 if x is less than or equal to 2, and it's 2x plus 1 if x is greater than 2. And we're going to sketch that piecewise function. Now, basically, it's got two rules. It's going to look like a quadratic when x is less than or equal to negative 2, and it's going to look like a straight line if x is greater than 2. So the first decision, because they do not give you for free the x's, is that you need to choose the x coordinates for your table. Sorry about the pauses, I'm just trying to get some oxygen here. X is 2 is called a boundary point. That's the value of x where one formula changes to a new one. And so when you know that there's a boundary point, in this case there's a boundary point at 2, you are going to choose 2 roughly in the middle of your table. And then you're going to move backwards and maybe do 1, 0, and if you think you need an extra 1, negative 1, negative 2. And this is the tricky part. You're also going to do a second 2 and then build upwards. And one of these 2's is, excuse me, one of these 2's gets used in this first formula, right? So if x is equal to 2, it is. The other 2, the red one, isn't used directly because this rule is only for x is greater than 2. The problem with that is the problem with that is that yes, it's bigger than 2, but it could be 2.00001 and we'd still use it. So what we do is we choose two 2's. The one that you're allowed to equal, I want you to remind yourself and put a solid dot there. And the one that is greater than or less than, the one that you don't get to use to put a circle around. So now we are going to fill in this table. We'll do it by hand. When x is 0, we're using the top rule. 0 squared, take away 1. 1 squared. 2 squared, take away 1. Now this guy, I know that you don't use 2, but since you can use up to 2, we can pretend that we can get as close to 2 as to make no difference. So I'm going to pick that as 5. That's going to be 7. And that guy is going to be 9. So this table of values is going to be used to sketch this fella. So here is my X and Y axis. And I'm going to do it in two pieces. These guys here belong to that row. So I'm going to plot them. What did we get? 0, -1, which is there. 1, 0, which is there. I guess I should put in some numbers. -1, 1, 2, 1. And 2, we got 3. And I know that these 3 dots make a curve. And I am emphasizing that last one with a nice solid dot. Now, technically, this shape continues, something like that. You then move on to the second block. 2 gets you 5. 2 gets you 5. You put a circle there. 3 gets you 7. 3 gets you 7, just about here. 4 gets you 9. Gets you here. And we know that these guys make up a straight line. And I draw a straight line. And then I basically continue that one and continue that one. So my piecewise function consists of a curve, quadratic curve, and a straight line. But more importantly, can you see that at the boundary point, I have a solid dot to indicate that we're using x equals 2 on the curve, and an open dot to indicate that for the straight line, we can come up to that point, but we never quite get there. That's what the little open dot means. You don't quite get there. How did that go, guys? Does it make sense?
Yes. Although I was wondering, how would you input a piecewise function into a calculator?
Oh, that is going to be number 3. Would you like to see another piecewise by hand before we start looking at how you would do these things on the calculator, including that piecewise one?
I'm feeling pretty comfortable to move on to the calculator.
Okay, so, I mean, once you've seen one, you've seen them all. Okay, there could be one with 3 pieces, in which case, wouldn't there be 2 boundary points and you'd have to increase your table to accommodate that? Okay, so let's use Desmos to sketch some calculators. My preference typically is, if I have the choice, is I always like to use Desmos because I just find it's easier to work with. So if you hold on a moment, I will zoom over here and let's do the first kind. The first type is pretty much what you see is what you get. Suppose you wanted to do an x squared minus 5x. Yeah, you just type it in. You might shrink it or move it around a little bit if you can't quite see it all, but you basically just type it in. It's good to go. If you wanted another example, how about y equals 3x minus 1? Take that guy out of the way. There we go. If you wanted to adjust the x values or the y values, hit this little thing here and say, oh, I want the x's for whatever reason only to be -5 to 5. And I want the y values to be, I don't know, say -15 to +10. And if you do that, then you can basically adjust the window to any shape or size that you like. So using your calculator, TI-84 is basically the same as that, right? You just do y equals, and you can adjust the window to make that happen. To show the same kind of thing being done on the calculator, this is what it would look like. Can you see a TI-84 right now, guys?
Yes.
Okay, so you would go y equals, and you could type in whatever the equation was, let's say it's 2x take away x squared. And you would go to window, and maybe you only want to sketch it from x is -3 to x is +3. So you would make x min -3 and x max +3. And then what I typically do, because it's sometimes quite difficult to judge the y values, is I go and I press zoom, and there's a whole load of choices here. And the one that I find the most efficient, most useful, is zoom 0, zoom to fit. So when I press that, the rest is done for me. See, it's kind of chosen a window, so the most amount of the picture is visible. Now, if you wanted to do a straight line, let's suppose we clear that out of the way, and you were going to do, I don't know, 5x plus 2. And let's say that your window this time was from -1 to +4, because that's what the table said it was. So y equals the equation windows from start to finish, and then zoom. And if you do 0, it saves you haven't to skim to the bottom. Zoom to fit. And there's your straight line. Now, piecewise functions can be done in a TI-84. I don't want to do them. They are ugly, they are messy, and I keep hitting the wrong buttons. So I'm going to show you how to do it on Desmos, which will be fine for your homework, because if you got a question in an exam, you'd be doing it by hand anyway. So you'd be showing me a table of values, very similar to the one I did 15 minutes ago. So let's look at how to do a piecewise function on Desmos. Right, so let's suppose, do I have that one handy? I do. This is the one that we did a few minutes ago. And so you type in y equals x squared take away 1. And then you do what I call curly brackets. I have no idea what you call them in America, but curly brackets, x less than or equal to 2, and you finish the curly brackets. Do you see you got this guy? And then you hit enter. And then you do y equals 2x plus 1. Then you do those little curly brackets. Oops, hit the wrong button. Little curly bracket. And this is for x greater than 2. And you finish with your little curly brackets. Now, the only thing that Desmos, and I'll move this around a little bit, do you see that it doesn't tell you whether that's a circle or a dot? Right, whether that's a circle or a dot. So I'm going to have to put these two guys in myself. When x is 2, you get the point 2, 1. 2, 3. There we go. Hey, do you see it fitting exactly where it should on the quadratic? Now, what about if you plug x equals 2 into the straight line? You'll get the point with coordinates 2, 5. And now you're going to say, oh dear, that's a solid dot, that's a solid dot. In fact, let me just label them so you can see them, right? But this one should be solid, indicating that when x is 2, use this one. And this one should be that open circle. Well, this is how you get open circles. Go over here and click on the left mouse pointer and hang on to it. And then you can choose that guy. And if you don't like black, you can make it green or pink or any other color that you like in the alphabet. And if I zoom in on that, can you see that that feature holds? Do you want to see another piecewise function using Desmos?
Sure.
Okay, so I'm going to have to kill these guys off. So let's do a 3-er. So I'm going to go back to my paper here first and write down an example of a piecewise function that has 3 pieces to it, which is typically about the worst you tend to get. So this function is going to be 2x plus 1 when x is less than 1. It's going to be x cubed when x is between 1 and 2. And it's going to be 4 take away x squared when x is greater than 2. So do you see in this case, there are two boundary values. At x equals 1, there's a changeover, and at x equals 2, there's another changeover. That's important because when we're finished doing the piecewise, and we're going to have a guy here and maybe another guy down here, we have to decide which one of them is the solid dot and which one of them is the open dot, because that's part of the graph, right? We need that information. So that's the guy that I'm going to do Desmos with. And if you can do this one, you can do it, all of them, I would say. So I'm going to start with y equals 2x plus 1, little curly brackets, and x less than 1. Just type it in as you see it. And the fact that we can't see anything is just that the window's been mucked about with. There you go, right? Then the middle one was x cubed, which is quite big. But you only do it for values of x, starting at 1, less than or equal to, so you press the less than and then the equals button, x less than or equal to 2, and then finish with a little curly bracket. And I don't know what happened there, little curly bracket, there we go. And so that blue bit represents this piece of the piecewise curve. And then the third and final bit looks like y equals 4 take away x squared. And then we do a little curly bracket, x greater than 2. So you can see that there's distinctly, they're all colored as well, which is kind of nice. 3 distinct pieces, right? Now there's a switch over at 1, right? There's a changeover from what happens at 1. Do you use the red or the blue curve? And then there's another one here at 2. Do you use the red or the green curve? So I have to find out what the coordinates of each of these points are. Let's do the red one. At x equals 1, the red one is going to be 2 times 1 add 1 is 3. So that's going to be the point 1, 3. And there it is. Now, since x is less than 1, that means you cannot use that point. So I press this guy, eventually, I press this guy and I change it to a little circle. And if you want to be color coordinated, I'll make it red. See the little open circle means you're not going to use that point when x is 1. Now on the blue guy, you're going to use it, and down here it's 1 cubed. So what would that be? That would be when x is 1, the y value is 1 cubed, which is 1. There's my point. This one is exactly what it should be, right? It's usable, it's a solid dot. All I'm going to do is kind of make it blue to keep the color coordinate system going. That's not necessary, but I'm doing it because it looks pretty. Now, at the other side, at x equals 2, right? On the blue guy, 2 is 2 cubed. So x is 2, the y is 8. And that's it up there. Should this point also be a solid dot, or should this one be an open circle? What should it be at 2, 8?
I want to say an open circle, but I'm not sure.
Okay. Do you see here that when x is equal to 1 and 2, you use the x cubed guy, you use a blue guy? That means that x equals 2 is a usable point, and a usable point gets a solid dot. So this one, in fact, is a solid dot as well. I'm just going to make it blue. Right, we've got one last guy, the green one, right? And when x is equal to 2, this guy is 0. So we have 2, 0. Now, I know that at that point there on the green curve, you cannot use x equals 2. So this point here is not a usable value, which means that to indicate that it cannot be used, you make it an open circle, and you probably want to make it green. And that is us. Maybe adjust it a little bit. There. A piecewise function broken into 3 pieces and showing open and solid points. Solid dots mean those points are usable. In this case, 1 and 2. The open circle here and the open circle here means you cannot use x equals 1, and the other one is you cannot use x equals 2, although you can use any value almost up to it. So theoretically, if I zoomed into that forever, wouldn't I be able to use any point up to, but just not that last guy, just that last guy, not him. Everybody else would be fine. Are we good? Do you want to see another one?
I'm feeling ready to move on.
Ready to move on? Is that general opinion? Are we good, guys?
I'm good.
Okay. Right. The last thing that is in my list is coming up right now. And I don't think we'll get it finished today, but at least we'll get it started. And that is, switch back. And that is finding the formula for a piecewise graph. Now, excuse me. Before we can delve into solving these questions, we need to kind of build up a little skill set. And the skill set we're going to look at, which is why I think we won't get this finished today, is how to find the equation of a line. So I want you to imagine that we have the simplest line I can possibly think of, and that is a straight line. And let's say that that straight line passes the y-axis at 3. Horizontal straight lines have equations y equals 3. You okay with that? Nothing really to see here? Okay. Now, suppose I have a straight line, y equals 3, I'll keep it as the same guy, but you can't use it for every value. It starts at -1 and it finishes when x is 2. Now you notice I've got a circle here and a solid dot here. And we want to try and explain how you would describe that equation. And you would describe it by saying y equals 3, but then you would have to tell people the range of x's where that was true. I put a little bracket for emphasis. And I just made my own mistake here. Now I've fixed it. It's y equals 3, but only use it for x equals -1 to 2. Why is there a greater than or equals on the 2, but just this guy, a single less than, at -1? What is going on here that makes that happen?
Is it the greater than symbol?
Well, yeah, what does this symbol mean? Well, it's got an equals in it. If there's an equals in it, it means you can use the answer and it's a solid dot. What does this symbol look like? This is just a less than. When it's just a less than, it means you cannot use that answer and it's a circle. So if I said to you, here's a different straight line then, y equals 4, and I told you that the restrictions on y being equal to 4 were -1 to 3, and you were going to sketch this guy, you'd find 1, 2, 3, 4, yeah? And you would find -1, 0, 1, 2, 3. And you would start at -4 with a solid dot, and you would do horizontal line, and you'd finish at 3, also with a solid dot. Why are these two solid dots? What here tells me to do that?
The greater than or equal to, right?
Right. Yeah, and in particular, it's the equal to part that matters, right? So straight lines, that's forever, but in piecewise functions, you're going to get bits of lines, starts and finishes. Now, suppose I give you a picture of a straight line, and it starts at 3 and 1, 2, 3, it finishes at 3. And this line is just a nice line that goes on forever, right? There's no restrictions on it. If I asked you to tell me the equation of this line, you would have to be able to write it like 4x. God, this cough's along. 4x plus 1 or 2x minus 3 or so on. To find the equation of a line, you need to find two things. First thing you need to do is find the slope. We call that m. And in a simple question like this, you'd look at the box and say, okay, the rise and the run, it's 3/3, so that's 1. And then you would recognize it isn't this pointing downwards, so we know the slope is -1. Are you happy about the slope of that line is -1 and how I figured that out? Just pick. Yeah. Now, the second thing you need to know is any point on the line. And I'm just going to pick, because I want to that point there, 0, 3. You can get the equation of alignment by using what's called the point slope equation, where y1 is this guy and x1 is that guy. So it's y take away 3 is m the slope, x take away 0 in this case. So y take away 3 is -x, because nothing doesn't matter. And the answer we get is -x add 3. So if you want to find the equation of a line, find the slope of that line, find any point that you know for sure is on that line, and use the point slope equation. And that would be it. Now, what we'll be doing tomorrow then is looking at the equation of a line where it's not the entire line, but maybe just a piece, right? Like that little bit there. And what